Hello everybody, my name is Sepide. Me and Amir Raza Alavi, we work on image captioning using a vision transformer encoder decoder architecture. So let me share a quick story to illustrate the idea. Imagine a robot in your house and you ask it to bring you your keys. Without image captioning, it just sees pixels. It has no idea what it's looking at. Without image captioning, a robot might detect shapes or locations, but it doesn't truly understand the scenes. It just follows the rules. With image captioning, it can look at the table and understand a set of keys is sitting next to a coffee mug, and now it knows exactly where to go and what to pick up. And here I want to show you something cool. We built a system that looks at a photo and automatically writes a sentence describing what's in it. A vision transformer encoder decoder. But now why this is hard? You know, CNN RNN models, those are older computer vision systems. They struggle with global context and long range relations, which means they're trying to describe a whole movie with just one word. So definitely they lose all the details. And even your system work much better, but they need millions of photos and supercomputers to train. But here, with our vision transformer, we built this that works well without needing all of that. So that's why the overall and the key idea is simple and efficient baseline for semantic grounding. In the experimental setup, you can see that we use Flickr 30K, 5 captions per image using supervised learning, and for the evaluation, we use token accuracy, BLEU, METEOR, and clip cosine similarity. For the token accuracy, you can see that I evaluate for the training data we got 555 score, and the test data we got 43%, which means our training data not just memorizing, it learns a genuinely real pattern, which is good. On other caption quality matrices, and I here you can see in the bar chart, are BLEU from 1 to 4 and METEOR. BLEU means counts how many of our words match the human words. BLEU 1 means check single words and so forth, that which is has the highest score, and BLEU 4 has the lowest score. METEOR has different story. It gives credits even when you see a different word that means the same things. Clip evaluate semantic similarity, and you can see that its mean is 0.268, which is good. In the middle part, I gave you a real world example. As you can see that the ground truth says a boy in a swimming trunks is splashing in a swimming pool, but our model predicted a boy jumps into swimming pool. And you can see that the orange is the clip scores is 0.347, which is solid for this image captioning, which means that it learns frequent words and patterns, produces fluent captions as well. In the middle part, it partial semantic understanding, which means based on having, as you can see the scenes, it's has limit understanding of object interaction because of being complex scenes. So in the failure case, I just wanted to tell you something. The ground truth is children play with a candy machines, right? And the predict says a man in a bright green shirt is sitting next to a man wearing a mask. And you can see that despite having wrong caption based on the image, and the clip has almost zero, but we can say that the sentence sounds fluent and grammatically correct. So the model writes confidently even when it's wrong. This is exactly where clip is important. BLEU would give this near zero, but CLIP confirm it's a complete mismatch. And in the key site, we can see that the model is lexically strong but semantically limited based on the comparison of the model. Here I compared four models: CNN plus LSTM approach with other three vision transformers. Every single one of our model transformer beats the old version of CNN, and you can see that the score of BLEU one compared to other scores of the vision transformers, which means a smarter decoding uh, strategy, we have the better captions, that which makes sense. So, and also we having higher BLEU accurate word prediction with BLEU with low BLEU 4, a limited structural coherence, and moderate CLIP partial semantic grounding. So the conclusion says that vision transfer model outperform the CNN plus LSTM approach. And this is my whole conclusion. Thank you so much for this matter.